All right, we are live. YouTube, YouTube, people from YouTube. Welcome to Rust Berlin meetup. We have our. What are you doing? We have our keynote. No, I'm just kidding. We have some friends over here, and we just some Discord people, and we're just doing a little bit of a. I don't know. I guess just speaking and just talking, networking session together.
We're trying to maximize the synergy.
Maximize synergy, yeah. So let me check the live stream if we are running. That's your job, by the way, but
Yeah.
it's good.
Ubuntu, by the way.
This is Ubuntu, by the way. Wait. Let's go to YouTube. Uh, no, I don't want to review anything. Bro.
Go to Orhun test.
No. How many people watching? Hello, guys. Hello from Berlin. Why is it like taking forever to load? What
Chat, is this real?
is this real?
Chat.
Somebody's calling me.
Mic wrong or?
Mic wrong? I think we should be live. Ads. Hello. Welcome, guys. Larry, Lukas, Salmons, and Coco. What?
Blazingly fast.
Blazingly fast. 3 ads on a row, man. What? Okay, so I think this looks good. This looks good. Okay, so
Yeah.
guys, let's do a bit of an interview. So starting with Samuel. Tell us about yourself. Who are you?
So I am a crazy person who has had a parasocial relationship with Orhun for the last 6 months, and so I decided to come here to visit him because he's my favorite friend in the world.
Yeah, I don't think the same, but
Yeah, because he doesn't even know I exist. I just came here.
yes.
Yeah.
Thank you for being here, man. I have I don't know what to say. That was very emotional for me. Thank you. And like, what is your relationship with Rust?
I've actually only been using it for a year, but this year I've been using it a lot, like every day a lot. My fiance can attest to that. Pretty much all my free time I code Rust. Maybe when I talk about it too much, like she doesn't really care about the borrow checker too much, but
Okay.
yeah. I would say at this point I've gotten to a decent level, but only because I've been grinding very hard.
Yeah, that's I can see that. I mean, your projects, Ratatui, UFI, PDF types thing,
Yeah.
bunch of stuff. So Sermons is very productive, and we're happy to have him in the Ratatouille ecosystem. So he's great. So any message to the listeners right now, to the world out there? What do you want to say to them? Think of something meaningful, not 6, 7 or something.
Keep grinding, and your dreams will come true.
Yeah, thank you for that. Thank you. All right. Moving on to Discord person, Coco.
Discord here.
So, who are you?
Well, I don't know. There was like 3 invites for the Discord server, and I just joined. That's pretty much it.
Okay. Cool.
Like the role play of the Discord person, or I guess so. So
I don't know. It's up to you.
yeah, I like it. No, it's a really cool place to hang out. The Terminal Collective.
Yeah, sounds cool.
Have you heard about it?
No.
It's like a place where we share, like we talk about terminals and stuff, share each other's dot files. Really cool. We have a YouTube channel, so you should check it out. Yeah.
Yeah, I heard you're hosting a podcast
Yeah.
with me.
Yeah. Oh, yeah. Yeah. With Orhun. This guy. Yeah. You must know him. Yeah.
Yes. So, what brings you to here today?
Pretty much this conference. I mean, we're talking about Rust here, so it's quite exciting. I picked up Rust like 3 years ago. Keep doing CLI stuff, of course, since I'm in the Terminal Collective. But yeah, excited to see all these people gather here and what they're to say, pretty much.
Yeah, sounds good. And last thing, what is your message to the world?
I was gonna say keep grinding, but he stole it from me, Samuel. So grind even more. Grind even more.
Thank you, man. Thank you. Guys, thank you for being a part of this little networking session.
I just want to thank you for taking my time today.
No worries. And yesterday, too.
Yeah.
So, yeah, I can happily take your time whenever you want. It's all good, all good. Okay, anything else? You're going to give a lightning talk. Maybe you can just spoil a bit.
So basically, Ratatouille is the new Doom for Zoomers. We'll port Ratatouille to every platform, every possible funny screen that can display it. So that's my goal, and I've conquered 3 platforms at this point. So I will talk about that.
Yeah. So, what was your 3 platforms so far?
UEFI, so before the OS even starts, like close to the motherboard, the firmware level, you can run Ratatouille, and yeah, that's awesome.
Yeah.
And also in PDFs. So Types is an alternative to LaTeX written in Rust, by the way. And I use Arch, by the way.
I use Ubuntu, by the way.
And so you can write plugins in WebAssembly. So I made a library for writing plugins for Types, which renders your Ratatouille apps. And the final, wait, which one was the final? Oh yeah, on the Nintendo Switch. There's actually a Rust ecosystem for homebrew. So I made a library for writing Ratatouille apps for Nintendo Switch.
That sounds very exciting, man. So, what will be the next thing? Maybe I can ask this at your talk.
Yeah, keep that question.
I'll keep that question. Watch till the end.
Yeah.
Vim guy in Rust Rover meetup. They're calling Vim guy in Rust Rover meetup.
That's yeah, maybe I should.
Someone asking. Ferris is asking. Actually, you can read it from there.
Exactly, that's the goal. You are correct. That's the goal. I definitely want Ratatouille on pregnancy testers.
Yeah, Ferris, you heard him. You heard him. He's gonna do it. Someone saying hi to you.
That's my dad. Hey, Papa.
Shout out to Samuel's dad. Thanks for the family is here. Everyone is here. Happy to have you guys. So right now we have food, drinks, and people are just chilling. And I might maybe just steal someone for another interview. I'm just looking. Yeah, Samus is our moderator today, so
You assign me to that, or?
yeah, I assign you. You're assigned.
Thank you.
So Samuel's dad, you must be proud. All right, thank you, man. Thank you. If it has a screen, it can run Ratatouille. Absolutely, absolutely. So let me see. Let me wave at somebody for a little interview. Oh, Zishan is also here. That's cool. Anyways, guys, in the meantime, if you have anything that you wanna ask or you wanna say to me, I'm here. But otherwise, I'll just walk around. Just let me just walk around and walk around. So let's see what we have over here. He's back on the sitting on the front row, Salmon. Absolutely, absolutely. And this live stream is sponsored by two rats. One of them is here, here, and here. If you can guess which one is like the original Ratatouille mascot and which one is like the Chinese knockoff, you will get prizes.
This is the OG.
How do you why?
I don't know the bread, the colors, the eyes, everything is so.
Don't say that. I mean, he gets sad. Like
It's so cute.
yeah. Maybe we could ask the chat too.
I
Okay.
have a hypothetical question. What would you do if Disney sends a cease and desist that you can't use the rat with the chef hat anymore? You have to change the mascot.
That's really good marketing, actually. Like, we could probably write a blog post and say Disney is attacking open source.
Yeah.
And just create some drama and maybe do like 3 live streams and like some Hacker News post and then just go viral. That would be a really great move.
Yeah. So Disney, we really want to.
Yeah, Disney, please attack us. Thank you. Thank you, Disney. If any like software engineers from Disney is watching, guys, find me. Find me, please. All right, let me actually pull up the chat. Pop out. This is Ubuntu, by the way. Okay, one sec. How do I merge these two? Can I do this? No. Yeah, good. We have a chat screen now. You can say hi, guys. If you want to say hi, go ahead. You're on the big screen now. Guys on the big screen. All right, I'll just walk around a little bit, trying to find some people to talk to. I saw David somewhere. Where is he? Hey guys. Hello. I'm on live right now. Live streaming. Yeah.
Who are you again?
I'm just a rat.
Yeah, I've seen you.
Yeah.
In the walls.
Yeah. Hey, how's it going?
All right. How's it going here?
Good to see you.
All set up now? That's
Yeah, we're set up. I'm just walking around.
Saying hi to everyone.
So we have David with us, guys. He's the. What are you working on these days? Arch Linux.
Yeah, mostly SignStar, which is this signing enclave for Arch Linux. And sometimes ALPM, which is basically package management stuff in Rust.
Yeah, rewriting Pacman in Rust.
Yeah, someone has to do it, I guess.
Yeah, so doing God's work out there. Keep it up, man. All right, I'll walk around. See you guys. So let's see who else we can just get on the live stream. Where's my club mate? You get my club mate. So we'll probably start in 10 minutes. I will do a little opening talk, and then we will just go from there, guys. Hello, welcome, Mr. Welcome, Mr. I'm not gonna say anything else. just welcome. Maybe I can just stick this microphone to my hat. Hey, hello, welcome, Vaishnav. What? Yeah, I think it's great. It's the best position ever. Like, restore the chat, maybe. Where's the chat window? We should have a drinking game about how many times Ratatouille you mentioned. That's true. That's true. I think I'm gonna get drunk in that game for sure. Samus, type something in the chat. I'll make you a moderator. Type something in the chat. I'll make you a moderator. Is the gnome? Today we're rolling with Ubuntu guys. Yeah. Watch the latest live stream about Rust in Ubuntu. That was a great one. So we're just rolling with that, basically. So yeah, I'll just make Samus moderator. All right. So how do I make him a moderator? Put user in timeout. I think this is the setting. All right. Save. This should be good. Type something again. Type something again. No. Again. Yeah. Like and subscribe. Yeah, please, guys, like and subscribe. What this true? What this true? So this is Ubuntu. Ubuntu fast fetch. No, don't ban me. What? Ubuntu, by the way. It's good stuff. Guys, don't hack me. Don't please don't hack me, okay? No, I don't usually run GNOME actually. I use Neri, but to be able to mirror my screen to here, I had to use GNOME because Neri doesn't do that. Yeah, like. Oh my God, no. Where is? Okay, good question. Yes, Ratty. My bad. All right. There we have Ratty, guys. Resize and everything. It works. There you go, Ratty. Good enough. This is how you write. This is how you write commands. All right. You could use WL mirror for Neri. I did that once in it for Priva. Yeah, next time I'll do that. Sermon's taking all the credit in chat. What is going on? Oh, it's raining outside. It's raining. Very rainy, guys. Maybe I could show, but I don't want to just break my setup already. So let me ask you guys a question, just to have some interactivity. So, what is your favorite Rust library? Let's hear what you guys are gonna say. Library or project? Let's go with both of them. Check the stream health. Alright, seems fine so far. No dropped frames. Type in your favorite Rust library. Maybe we could just have the maintainer give a talk here. Maybe we could invite him and stuff like that. So it's the feedback is important for us. I think I'm gonna just invite myself. What is your favorite Rust library? Clap.
Of course, Ratatouille.
Ratatouille is the second. Clap is the first one. I use Cosmic Desktop on Arch. Have you used Cosmic?
Never.
Never? I also never tried. I mean, I use Ubuntu, so like, GNOME, just running GNOME. Saturday. It's a good one. Good one. Color Air. It's a good one. Maybe ask Coco. Favorite Rust library? Antic from David Tolnay. Valid answer. Valid answer. Yeah. Yeah. What is this? I just joined. This is Rust Berlin Talks. We're gonna have some speakers in a minute, and we're just kind of like just chatting right now. And if you want to see the lineup for the talks, there's a link in the description. And yeah, that's what it is. Rust is a programming language, and yeah, it's the best language after Holocene. And yeah, welcome. Die Stoppard. Hallo Leute. Hallo, herzlich willkommen. So, 3 minutes away from the talks. Let me try. This thing works. Yeah, it works. Cool. I'll have some slides. Yeah, we're gonna. That. So we basically gonna do like a little roster updates and then start with Lukas' talk, and then Leon will also give a talk. Let me pull up the agenda to give you guys more info. So the first talk, powerful macros, good IDE support, no headaches, and the second one is reactive programming in Rust. I heard Zig devs are converging on your location to show you what a true. I didn't even read it. Cool. Did he just delete his comment? I didn't see it. It just disappeared. Your message just disappeared. Did he ban him or what happened?
Time of 10 seconds.
Ah, okay. But he, I didn't. Sermons, don't ban people for no reason. I mean, let me at least read it first, you know? Let me read it and then ban them, you know? It's fine. We are sorry. XONOFAXCS2. We are terribly sorry about the inconvenience, but we don't allow any other programming languages. You mention anything else, insta-ban. My moderator is just sitting with his phone on his hand on the ban button, okay? Nah, we're just kidding, we're just kidding. Only Rust and Holy See allowed though. Only Rust and Holy See. Nothing else. Roland is commenting. All right. I need to get my club mate though. This suspense is unbearable. The vibe suffering. I think we're gonna start in 5 minutes, so it's fine. Until then, just vibing. Just vibing. Yeah, we all good. Emacs, Vim, what? Alex, anything? Guys, this is a Rust live stream, not an editor piss fight, okay? No. Rust Rover, if someone mentions some other editor than Rust Rover, just ban them. Nano, the simple, I don't know. Get it. Yeah. I mean, I get it, right? I get it, yeah. I get it. Z or Envim, actually. So yeah, like if anyone says something outside of Rust or Rover, ban them. Rust over. You forgot the R there. One is bigger than 0. That's wrong. Like, subscribe, like. It's a Rust talk, and he's working to just print. Even if I'm a V user, respect that company. Mentions of any other for 1 year. Maybe let's not do that because it's too short. So, I mean, they could just come back 1 year later. What's the point? Maybe 10 years or something. All right, let's actually start. Your actions have consequences. V user. Where's Lira? Do you prefer to put this on your hat or on your shirt? Okay. Rust Rover Vim plugin. He found some workaround with that. Rust. Smart. What? Idea of him. Yeah. I think that's allowed. Maybe 6 months of ban is enough, like, because 1 year is good. Like, no, I mean for him because he found like kind of a, yeah. You cannot ban me. Idea of him permitted. All right. All right, everyone. Let's get started. let me actually go back to here again. Welcome to Rust Berlin Talks, everyone. It's good to see you here on this rainy day in Berlin. A lot of Rusticians came together, a lot of new faces, old faces, same faces, let's say, not old, I'm sorry. All right, so before we start, we have some updates. So first of all, in case you don't know me, my name is Orhun Parmaksız. I work at JetBrains as a Rust developer advocate. I'm also an open source developer. I have some Rust projects, Ratatui, maybe you have heard of it, other stuff as well. So I'm pretty active in the Rust community and super happy to be, hosting this event and just bringing all the Rust people in Berlin together. And even outside of Berlin, I mean, we have somebody from Japan here, right, Roland? All right. So before we go into the talks, we have some updates from Rust Rover, and I'm going to just tell you what we have did as a Rust ecosystem at JetBrains. So we have just released Rust Rover 2026.02, and in this new release, we have some cool features. So I'm just going to show you what we have really quickly. And this was released just recently, yesterday. You can go ahead and install it. So first of all, we have support for web backend frameworks, Åkesson mainly, and this means that you can now your IDE knows about the Åkesson projects, and you can simply go in and explore your endpoints, and you can jump back and forth between the handler functions and your endpoints and all the routes in an Åkesson project. We have also added, let me go back here, added some nice UX to this new UI. We have automatic documentation fetching. So whenever you have some kind of a doc comment as a part of your API, you can just see them there. Also, you can generate example code. We support the request library in Rust, so you can just generate client-side code for your endpoints and just simply use them in a, let's say, a test client application. We have Ferrocene toolchain support. Ferrocene is a compiler for critical safety systems, and now Rust Rover has code insight for the Ferrocene toolchain, and it recognizes that you are using Ferrocene, and it gives you some hints and also some warnings and just guides you to fix your setup. So in this example, you can see that it wants you to add a stdlib source to be able to use the Ferrocene. We have an interactive macro tester. This is quite an exciting one. If you have a Rust macro, you can now go to this UI, which is new, and we'll show you this macro tester where you can see your macro, you can see the input, and you can see the output. So you can just play with the input and it generates the code for you. This means basically just live debugging the code generation inside of the IDE. It also checks the syntax, of course, and kind of highlights the parts that are being generated. So if you have a literal, it just like kind of maps to whatever it's being generated, like so. Also, little UX improvement. You can now run criterion benchmarks inside of the IDE. Oh, this is kind of weird. And it's just like an additional button where you can just run the whole benchmarks, and it supports fetching the logs and just shows stuff to you as usual. And last thing that I wanted to mention, of course, we have more stuff in there, but now in case you want to you're working with a tool such as Cargo ASM to get some assembly output of your code, you can now use the you can now use this new like copy fully qualified path copy reference feature, where it will copy the whole reference to the function instead of copying the name of the function. So you can simply get this output like from your function. This is just a little UX thing that we have. We also did 2 new live streams this month. One of them was with how do you rewrite C and C++ projects to Rust with Luca Palmieri, and the other one was just this week, Rust in Ubuntu with John Seeger. In case you want to watch these, I'll just put this up for maybe 10 seconds if anyone wants to scan the QR code. And Luca is working at Main Matter, and he has a lot of insight about how do you rewrite things to Rust. All right. The next one, Rust in Ubuntu. If you are curious about how Rust is being adopted in Ubuntu, you can watch this live stream where we talked about sudo rs, GNU core utils, rewrite, bunch of other things that Ubuntu is doing, and it was quite fun. I also hosted this one, so you're gonna see me there, unfortunately, again. All right. Rust Rover is a IDE for Rust, for working with complex code bases, and if you like to use it, if you have a complex Rust project, and if you're just looking for a powerful tool, definitely check it out. So yeah, with that, we're gonna just go to our talks. First, we have Lukas from Z Industries. Z Industries is the company behind the Z editor. Lukas has been working on Rust Analyzer since 2020, and he has led the team since 2022. He has also contributed to Ferrocene language specification, and he maintains an updated fork of the little book of Rust macros. And today he's giving a talk about macros, powerful macros, good IDE support, no headaches, and choose to. So Lukas, we're gonna just invite you to the stage. Just put this. Also, don't mind another microphone. Yeah. One for the live stream, one for the.
Right. Bit lower, maybe.
Yeah.
Yeah.
Can I just put this in your pocket?
Yep.
Good.
Yeah, this. Yeah, just.
If it's still working.
Okay. Should not. Okay, that works. Yeah, I mean, I just got introduced, right? So I can skip that part. I'm here, well, some of you, the people that have been at Eurorust in 2023, might have seen this talk already because I gave it there once before already. But yeah, I'll be talking a bit about macros and why they are kind of annoying for IDEs and why they sometimes cause weird issues for diagnostics and, well, for some of the IDE features. Yeah. But to start with, I want to show you a very funny macro that I've seen in the past, which is one variation of it. This one allows you to write Rust in German, for example. And this is a screenshot of, well, from in this case, from Z. And as you can tell, like highlighting and all is semantically correct in this. Like this is using semantic highlighting. All the tokens are going through a macro and the IDE is actually able to correctly tell the semantics of it. So for example, the gefährlich here is technically unsafe, like the keyword for unsafe, right? And in my theme, it's correctly identified as like red background because of the unsafety behind it. But this macro has a lot of variations. The initial one was, I think, French. It was rouille, yeah. So there are like a lot of forks of these, and it's not limited to just like an ASCII character set, right? You can have it in Chinese as well. It works all the same, which I find very interesting to see, this kind of flavor of Rust. But what actually enables us to do this, to be able to tell all of this? And the underlying thing for this is effectively what the compiler calls spans, which are really just the source location of something. So basically a file and a byte range that defines a position in the source code. But it also has some extra info, which is the macro expansion context, also sometimes called syntax context, or also more commonly known as hygiene, which kind of defines whether, like in what context a given identifier resolves. And so let's look into how this actually looks like. If you have a proc macro, you can actually inspect the spans because proc macros have APIs to work with the spans. And in this case, we're just printing the debug representation of the span. If you run this through rustc, this is roughly the output you'll get. Not very descriptive. In rustc, all the spans effectively are just byte ranges of all the files as concatenated results. Rust analyzers is a bit more convoluted because we have like put our focus on different things for one incrementality. So we have this weird thing called an anchor, which is effectively just some random item in the source file. And all the ranges for the span are then relative to this item. And then we also have this syntax context separately. So what do these spans actually do? Obviously, they predate IDEs, they predate semantic highlighting, and so they had like some purpose before IDEs even were a thing. And it's mostly for diagnostics. Spans allow the compiler to give you proper, nice diagnostics that point to correct things. So here's, for example, a macro that does invalid arithmetic in its expansion. If we didn't have spans, this would probably be the best we would get for the diagnostic, which is not that great. Now you have to dig through the macro to actually realize what is going wrong somewhere. So the actual diagnostic that you get is actually this one, right? It actually points into the declaration side of the macro and tells you, hey, this is actually the cause what went wrong. And yeah, as I said, proc macros have a variety of ways to like change the spans of things. So spans are usually associated with a token. And I will kind of interchangeably refer to spans as tokens and spans because it makes things easier for me. But this obviously means proc macros have a lot of power in how they can shape diagnostics and likewise how they can shape behavior of the IDE in terms of specific features. And this can cause weird issues as well. If a proc macro does something kind of incorrectly or in a way that doesn't quite fit with what the compiler wants to do, you might end up with funny things like this. This is effectively wasn't bindgen, like the user just made an error called await on something that is a unit type that is not a future. So now the compiler correctly tells you the unit type is not a feature, but because the spans of whatever the macro is internally doing are kind of being thrown around incorrectly, it now basically suggests to remove the attribute and edit again. Like, just try it again, maybe it works next time, right? This is what happens if spans don't quite align, because the compiler can't perfectly tell apart when something comes from actual source and when it comes from macro expanded source, due to implementation reasons for one as well. So let's dig a bit deeper into this. How can you actually associate these like inputs to outputs in terms of like input tokens to your macros and the expanded form of it? So I have like a couple example macros that we will briefly go through. It's effectively one macro that just reuses its input once, then twice, and then not at all. So I'm showing this with hovering. So if you hover the input, we would expect the IDE to resolve this to the actual semantics and the expansion, right? So this is the macro that only used the input token here once. And so our expectation will be, it should basically treat this as if you were hovering the definition identifier of the struct.
And this would work for all kinds.
Yes, yes, exactly. As long as it's like used once, this is exactly the behavior you should be going. We should be ideally perfectly be able to tell, hey, this was used in the expansion like this, all as well. In a similar vein, if it's used twice, we would expect it maybe to show the hover message for all the items, right? So in this case, we have the struct at the top because, well, in this case, the struct is the first definition. And then below, we have the function as well, because this token actually now refers to multiple entities in the language. And then finally, we have it not used at all, in which case I am hovering here, but you can't see anything because there is no semantics to this. So there won't be any hover information here. Right, so to recap that, well, to clarify, obviously these were declarative macros, right? So these are like the simple cases. They don't really do anything unexpected. But for proc macros, because they can throw spans around however they like, this can produce excellent diagnostics if used well, because you are in control of basically annotating what you think the diagnostic should be pointing to. But overusing or misusing them can also cause a lot of issues. So as I already showed, misleading error locations or misleading quick fixes by the compiler, like the compiler suggestions, incorrect semantic highlighting, so tokens suddenly are colored completely incorrect, weird hovers that have way too much information of unrelated things, and more, like completions not working as expected. So the goal here is obviously don't avoid using spans and proc macros entirely, but use them reasonably. And we will get to that, what that actually means. So with that said, I want to go into an example with the Tokyo main macro that caused us some issues in the past for a variety of reasons. One being the macro not cooperative enough, but also because Rust Analyzer was a bit bad with its heuristics. So to recap, this main macro, all it really does is it expands to roughly this code. It really just takes the main function and shows like the body that you wrote into a multi-threaded runtime or whatever like runtime you basically chose, right? The interesting bits to this we come in next, but effectively we had a bunch of issues like these where people were complaining that the main macro, the test macros and so on from Tokyo and a couple other crates as well, were having very weird like syntax highlighting. Obviously not visible in this clip now, but also another big complaint being that usually completions didn't work if you were typing in the end of the function. And the reason for that is because of the expansion earlier. So in this case, the highlighting is now correct because unfortunately this is from a newer version already. But we can still see the hover here is a bit weird. We get the hover for our structs, but weirdly, like hovering this token. But weirdly, we also get the hover for Tokyo. And as you can see by the scroll bar on the very right, it's very, very tiny. There's a lot more in this than just this. And it used to be the case that this order was like all thrown around actually, but due to like changes with our heuristics, we at least show the most prominent thing at the top now. But yeah, what's the cause for this? Well, if you hover that token from earlier, you are actually effectively hovering every single token that is highlighted here, because all of these have the same span. That's not great. We shouldn't be doing this. But why is Tokyo doing this? Well, it's because of diagnostics, as I said earlier. This snippet here has a type mismatch, right? It should return unit type, it returns the result, so the compiler will error on this, and this is the error message that we would expect, right? It shows you where to insert relevant information, like the return type or like an unwrap. But if Tokyo didn't reuse the spans like it did so far, this is actually the result we would be getting. This is very much wrong, right? No one wants this. And so obviously it has a use case here. So we need to do this in some way. But can we make it better that it doesn't confuse the ID as much? And it turns out there is a way. So going back to this, we just said like all of this has this weird span, right? But we don't need all of this. We are interested in the type mismatch diagnostic. So in this case, we only need to figure out which of these tokens is actually affecting the diagnostic. Oh, that's a weird transition. That shouldn't be there. Well, turns out it's only this one. This block on token is the one that actually emits the diagnostic. So we only need to put the span here. All of this other stuff doesn't need the span. This already would decrease the hover size by a lot, right? Because now we don't have an effective hover on every single token there, just on one extra thing. But there's more to this. Recall the initial thing that we wrote was an async fn main with the body in it. This is very different. We removed the async at the start. We moved it here. We moved the body in here. We introduced some extra let statements on. We don't actually need to do all of this. We can effectively just take the user written function, move it into the local scope, and use it as is. So we don't even need to transform the input at all. This has a lot of benefits because now effectively everything the user wrote has a concrete, unmodified target. This usually helps in preventing completions from breaking down the lag because we are once again retaining our spans. With all of these changes, Tokyo mostly works now for us, including like other attributes and macros in the wild. But yeah, I thought this was a very interesting thing because I had like made a big deep dive into this to actually figure out what was going wrong. But yeah. Another issue here though is incomplete inputs. So going back to the fact that I don't know how well everyone is aware with this, like of the folks that are actually using Rust Analyzer and not the JetBrains products. In Rust Analyzer, there's quite often the issue if you type in macro code or in an attributed macro code, completions tend to just stop working at all, which is weird, right? It looks like normal Rust. It should work like normal Rust. The issue is usually the fact that proc macros tend to use sin. And I don't want to mean this in like a bad way, like don't use sin, sin is bad or whatever. The issue is the way sin works. Usually you have kind of this structure here. And if this parse macro input gets input that is incomplete or not what it expects, it errors out and replaces the entire thing with a compile error invocation. That means as soon as you type anything in the function expecting completions, you now have incomplete code in the usual sense. And Rust Analyzer loses all semantics because we don't have the input anymore. All of it got replaced with a compile error macro invocation. And so there's not much we can do here. And that is unfortunately the issue with sin, that it is very, oh, I should have switched to this earlier, sorry. But yeah, this is the effective output. And that's just an issue with how sin works by default. So people actually need to go through hoops to make this work a bit better. Yeah, that's the expand for that, exactly. So usually what one should be doing, instead of just bailing out and replacing it with this error, you should try, alongside this error invocation, you should try to expand something that closely resembles what the successful case would be expanding. So we, at all times, effectively retain the semantic information that we would have in the successful case, which then allows Rust Analyzer to closely figure out what the completion should be, what the expected stuff is, effectively. Note that this mostly affects attribute macros. It also technically affects functional proc macros, but those usually are a domain-specific language anyways. There's not a lot of completions that can be done there in the first place. And then there are derived macros, which usually do not really care about this because derives do not replace their output, right? They just append. So derives are usually, like derives, this is completely fine to do normally. Which brings me to the next topic, which is impure proc macros. Technically, it's just a token stream to token stream mapping, but that's not quite right, right? We have proc macros that do a lot worse. I don't know, if you think of a bad, like a naughty proc macro, what comes to mind? What? There would be one. Grab time, yeah, exactly. And what I like to bring up is SQLX, right? Spinning up a database in your proc macro and such. But like spawning processes or like writing to files, reading files is not the worst that you can actually do. This is the worst you can do. This is a proc macro that, well, it only runs on Unix machines. It doesn't actually run Windows. This just forks your compilation session and basically tries every single branch that exists in a separate compiler process until one of them succeeds, or well, none of them succeeds. This works fine with the compiler because the compiler actually loads the dynamic linked libraries that proc macros are, and well, it just forks, it just kind of works. IDEs don't really do that. Both Rust Analyzer and Rust Rover do not load dynamic linked the dynamic linked libraries into the process itself. We actually spawn a separate proc macro server process that loads these, simply to prevent macros like these from actually destroying the analysis session. Because a proc macro could also just call into a std process abort or exit, and that will kill the compiler session. And we don't want that to kill the Rust Analyzer session. Or it could segfull, right? It's just a dynamic linked library. But what actually happens if you were to run this in Rust Analyzer? Well, it just kills the proc macro server effectively. So now you lost like all your proc macro support until you restart them, which is not great, but it's better than completely losing the IDE session. So with that said, proc macros can be very non-deterministic and side effectful. There are ones out in the wild even that are dependent. Well, I would assume not anymore, but there used to be some that were kind of depending on the expansion order, which is completely not defined by the language. But yeah, many other things, right? Files, time, network, anything you want really. Which, I don't know, I hope wasn't proc macros will fix this, because they should be more pure, but we're not there yet. More importantly, the compiler and the IDE cannot track these hidden inputs, right? Like reading files is an input, but there's no way for the compiler or the IDE to know this. The compiler today does not cache proc macro expansions because it would break all of these. And there are, like SQLX, for example, these are proper proc macros being used in the wild. Rust Analyzer, though, and I don't know about Rust Rover, but at least Rust Analyzer actually does cache them. So we don't care if we miss these hidden dependencies effectively, because if we were not to cache them, it actually breaks our incremental database engine. We used to have a lot of fun with that until we figured that out. So that's why sometimes for some proc macros, you might see stale results in your IDE. The order I basically spoke about. So order is not defined. Some proc macros in IDE sessions might not even be executed because you never even revealed the code, right? Then I have this interesting snippet. So this is 30. Everyone, I would assume, knows 30. And 30 has a lot of like configuration things, right? You have all of these small helper attributes that can kind of change the way it works, which is really convenient. But there's one annoyance with this. All of these that take like proper custom options, like the Wirth command here, they take strings usually. And this is kind of annoying for IDEs. The reason why it uses strings and not like bare tokens is simply because 30 predates Rust, where bare tokens were actually allowed. Back in the day, you were like this form of attribute invocation basically only allowed strings and integers, I think. Nowadays, it takes any expression string. But the reason why this is annoying is it destroys spans. Like this string is one token, right? Internally, it repasses this into the proper path. But really, this is a lot of tokens that it technically would be. And so if we remove this string, we could associate the spans correctly for every single token. But because it is one string, we lose all of this. So no IDE features actually work on this, which is very annoying. Like no hovering, no highlighting, no go to definition, no reference searching, all of that doesn't work. We could make it work, but it would be really, really tricky to get right and also really annoying. And I don't think it would actually work the way people want it to. And so if Surdy ever like does a 2.0 release, I don't think it will happen, but it would be nice to fix that. Yeah, specifically these. Whereas like comparing this with, for example, bin RW is a derive that actually does use just proper tokens, and you can immediately see like my syntax highlighting, my semantic highlighting is just working. For example, yeah, I mean, you can see like the static here is yellow instead of the local black and so on. And yeah, hovering works for all of these. Go to definition works for all of these. Rename works for all of these. That's honestly, I think, one of the bigger ones. Yeah. So I mean, I mostly spoke about proc macros, really, right? So what is actually about what's up with declarative macros? There's not much to say about them actually, because you can't change spans with them. All you do is you take tokens in, you put tokens out. That's like all you do. So there's not much you can really do wrong with these, aside from expecting a concrete identifier and then like not capturing it in a meta variable or something. But really, there's not really a lot of problems with these. So usually it's just proc macros, as usual. Which then brings me to the last topic, which I already kind of spoke about, which is completions breaking randomly. Just to like shed a bit of light on that. The way IDEs usually do completions is we take the cursor position and we insert like a fake identifier. Reason for this is if you haven't typed anything at your position, inserting this identifier allows us to reconstruct the tree as if you had typed something. So we then can figure out what the actual like semantic context is. So it's effectively speculative execution, right? And that means it is like the inserted identifier effectively is very, very important for this speculative analysis. And if the proc macro, going back to like the replacement with compiler or whatever, completely discards this one identifier, you lose all semantic info. If it puts the identifier somewhere completely else, it will cause us to like propose very incorrect completions, right? But you could also use this to your advantage. You could, if you could figure out, hey, this is a completion identifier in your proc macro, and you want to inject like very specific, like domain-specific language completions, knowing that you could like try to emit some really weird Rust code that is just used for this to like guide the IDE to set those up. I don't think anyone ever really does that because it's a really weird use case and, well, not really described anywhere. But I think it's kind of neat that you could do this to get like proper support for your domain-specific language if you go through enough hoops for that. Yeah, and this is also kind of why Rust Rover handles this nicely as far as I'm aware. Rust Analyzer doesn't really, because we actually lack the capability to do proper speculative execution. Because effectively what this identifier insertion does is you get a new parse tree, and now you want the semantics for this new parse tree. That means in theory, you would need to run your entire analysis on this change tree now. But we don't actually want to discard the previous analysis we had. So you technically need to fork your state and just have it temporary to be able to do that. And Rust Analyzer can't really do this right now. So what we actually do is just we create this fake tree. We walk the previous tree and try to like cross-reference the semantics, and it tends to break down really easily, unfortunately. But yeah, so with that said, obviously this was a bit chaotic probably because there's not like a one big timeline of things that I went through, but more a bunch of different issues and things to talk about. But this leaves us with basically kind of these rules in using spans correctly. So one, as we said, for IDEs at least, they associate input and output tokens. For the compiler specifically, it tells it where to emit a diagnostic, where to point the diagnostic to. You should, in your proc macros, recover from unexpected inputs. So try to create output that matches your ideal expansion as closely as possible, no matter what weird input you might be getting. Do not panic in proc macros. I did not mention this actually, but if a proc macro panics, it is effectively the same as if you were not emitting any output. So panicking and replacing it with a compile error invocation is basically the same thing. The compiler also doesn't like this as much because I think it does cause basically worse diagnostics than just using a compile error invocation. Yeah, ideally accept input syntax like the way it appears in the output. So basically, as I showed with the Tokyo example, try to modify the input as little as possible because that then just naturally retains all the spans. Don't depend on side effects. I think this is self-explanatory. There's seldom a use case where you actually need to read a file or something weird in your proc macro, I believe. And lastly, if you can avoid it, don't use macros. That's always been my stance. I don't like them too much, even though I put a lot of time into making them work in Rust Analyzer. But usually they are not that necessarily, well, necessary, I guess. Yeah, that's it.
Can take some questions. In the proc macro, is there a possibility to check for this fake identifier for the completion? Or how could you check for it?
With Rust Analyzer, I don't think so. Rust Rover, I think, experimented with it. I believe they set an environment variable when expanding proc macros on their side. But yeah, otherwise, basically inspecting the token's text and tell it, because it is always going to be the same token. Like for Rust Analyzer, I think it's RA completion marker or something like that. But yeah, we haven't really investigated into like how nicely that would actually be workable. But yeah, the ideal idea would be to basically set an environment var at runtime. I think that kind of tells you, hey, you are actually running as part of Rust Analyzer's completion or whatever. It would be the idea.
Thank you. I was curious, has there been sort of any exploration to, particularly for like the proc macro cases, if authors of these macros could communicate the error state somehow in a way that Rust Analyzer or Rust Rover could use? Because I know you're always like, you know, give us something and we'll do it. But has there been sort of talk of like a specific possible protocol or anything?
Well, there's no need for like protocol changes or anything. It's really more like there's a crate that is missing in the library ecosystem, effectively. What really, like the thing is, like Syn is an infallible parser, basically. You get an error, like something unexpected, you just bubble that up and that's it. What we actually want here is a parser that allows easy recovery. You want, yeah, parser recovery, effectively. And then like accumulate the errors and then just at the end of your parse, emit with whatever like broken setup you end up with. Emit that and also
something very anyhowish.
I wouldn't even compare it to anyhow, I think. But yeah, it's really just parser recovery effectively. So like the way IDEs basically, well, also the compiler recover from incomplete syntax to still continue the compilation session up to the specific point. You just want to see like, oh, this token is missing. okay, I'm recording that, it is missing, and now I'm just filling in some dummy and continue with my parse. This is kind of what you want to do. But there's no library for that yet, because frankly speaking, it's not that easy to write in a generic way. And that's, I think, mainly the reason. I know there are like posts on the users and internals Rust forums, I think, where people are actually talking about this here and there, but I don't think anything has happened in that regard yet.
Last question.
Hi, thank you very much. One quick question regarding to the Tokyo example. What would you actually assign to all the tokens that you didn't assign the span to from the input?
So I don't really need to go back here, I think, but for spans, so obviously you have spans from the input tokens that you can reuse, but there are 3 more like default spans that proc macros have, one of which is technically unstable, so you can't use it yet. But there is the so-called def side hygiene, so definition side hygiene, mixed side hygiene, and call side hygiene. And effectively what those refer to is definition side hygiene is effectively the span of the proc macro definition with, well, def side hygiene, which means the name resolution cannot actually touch on anything that is outside the macro expansion. That's the unstable concept effectively. Then you have call side hygiene, which is the location of the macro invocation. That is the default. Anything you, like any tokens or things you create in your proc macros by default have call side hygiene. And so any diagnostics associated with them will point to the macro invocation. That is, for example, also the case here. This is only pointing at this part here because this is the call side hygiene. And the spans were not set up correctly, so this just points to the call side hygiene. That is causing this issue. And mixed side hygiene is, well, a mix between it. Mixed side is actually what declarative macros use. It is still hygiene, still the span that points to the call side, but the name resolution context is a mix between definition side and call side. Specifically, it's just macro rules tend to have local variables that do not leak outside of the macro. That is definition side, and almost everything else actually leaks out of the macro, and that is then call side. It's a weird interplay in that.
All right. Thank you so much, Lukas, for your talk.
All right.
Okay. Moving on to our second talk. We have Leon Matthes from Slint, and he is a software engineer who enjoys diving deep into programming language semantics. And today he'll be speaking about reactive programming in Rust. Welcome, Leon.
Sorry.
Yes. Okay. Hello. So first, Hi everyone. And first, thanks to Lukas also for his talk and also for his amazing work with Rust Analyzer. Also, sorry, Lukas, for all the bad shit you have to put up with because of projects like Slint that generate a ton of code from for example, macros, because Slint is a toolkit that comes with its own domain-specific language that you can also put in a Rust macro, and it will then generate you Rust code that Rust Analyzer will have to deal with. And let's find my. And today I wanted to talk about the. Oh, first I need to find where my desktop is. Okay. It's looking not too bad. Okay, and today I wanted to talk about the programming paradigm that underlies the Slint implementation, which is reactive programming. And in a sense, this kind of solves one of the two big problems that we have in software engineering, which is cache invalidation. So I kind of like to think of it as being able to cache a lot of things without going insane by having to all the time invalidate or forgetting to invalidate caches that you set up somewhere. And first, I want to have a look at a sort of typical UI problem, which, oh my god, this is way too tiny. Maybe we can halfway see what's going on here, which is sort of login dialogues. So this sounds like a very simple problem, really, right? You just have a bunch of input and then you create an account, right? But really, we want this to be nice and reactive, right? We want to, as soon as I start typing something here, we want things to update. We want to get feedback. That's really kind of the most important thing in UI development. And we want to get it continuously. This is actually very similar to, for example, Rust Analyzer, right? We want to continuously get feedback. And that makes things very different to when we have a straight processing loop. That's why we have Rust Analyzer as a separate project to the Rust compiler, because the Rust compiler can just rely on, well, I get some input, I try to generate the output, and if it doesn't work, I'll just bail out. That's not what you want to do with a user interface, right? You want to allow partial inputs, you want to allow conflicting inputs, and you then want to get nice diagnostics. Get the window to resize correctly. So in a sense, this is very similar to the kind of problem that we have with Rust Analyzer. And we want this to be reactive, right? We want this to happen immediately. And we want to, for all of the multiple inputs that we gather, we want them to combine nicely and to react nicely together. And if we try this with the sort of standard imperative approach, right? How you would write it in most imperative programming languages, including Rust, you would maybe start with some kind of struct that contains both your inputs, right? Your password and your username, and then also contains the data that you want to show to the user. So, for example, the status of the password, whether it had any errors, whether the username is available, that sort of thing. And you might have also noticed that the button at the bottom will only become active when I actually enter a valid password, right? So very typical input flow. And this seems like a simple problem, right? We just set the username. If the username is available, which in this case it always is, we update our status. And then the password is just slightly more complicated, right? We get the password, we assign it, we check if it's empty. Otherwise, we check whether the password that has been entered contains any problems, like is it long enough, that sort of thing. And then we just either allow you to go forward or we give you an error message. Nice and easy. And then when we check the password, it's just super simple steps, right? We create a list of potential errors that we can get. Then we check each individual condition, assign the errors, and then we return the error list. I know this is slide code. Please don't actually check passwords this way. And this is what we just call from our set passwords function. But there is a subtle bug here that you may not realize if you've just written this without paying too much attention to it. But has someone spotted it? No, that won't actually happen. We'll replace the errors every time. That's not really a problem. So we just recalculate them every time. That's fine. That's okay. Sort of, you're going in the right direction, definitely. Because the problem is that we have multiple inputs here, which you might not realize, right? The whole function is called check password. It gets the password a couple times, but it also gets the username, which is input that may change at any point. So our calculation for the password status depends on the username. And this is super easy to miss, especially if you, for example, started with the upper part and then added this check later, right? All of your update logic depended on this only having a single input. And now it's screwed up. If I now enter a valid password and then change my username, I won't get any password checks, which might mean I can now add a username that is the same as the password. And again, please don't actually check your password only in your UI, like have a proper check after you've entered everything, just to be sure. This is not security advice. So the problem becomes a bit clearer if we look at it a little bit like a graph. And we can see here that there are these multiple dependencies that are going on. And both our username and our password are actually input to our list of errors, which then also actually have multiple things depending on them. So here, it's both the button active and the password status, which again, we never actually updated the button active in our username function. So again, this is really easy to screw up if you actively have to update things. And this is really where reactive programming can help us. But what the fuck is that reactive programming? So if we just copy the definition from Wikipedia, it tells us that it's a declarative programming paradigm concerned with data streams and the propagation of change. And it's especially the later part here that I find to be the most important. And that's also why it's the core paradigm that we use in Slint. Because in Slint, we constantly have this problem that things are constantly changing, and we need to detect where we need to propagate this change to, especially if we have this kind of graph. And in Slint, we specifically use these terms here for these kind of programming graphs as where we have data points, which are properties, which you can kind of think of as caches, which is why we're sort of talking about cache invalidation today. And then we have connections between them, or calculations that where our data depends on, which are bindings. So this is a term you'll often also hear, property bindings, which often is the same as reactive programming. These are often intermixed. So if we try this again in Slint, which again is a domain-specific language, which compiles down to Rust, we add our password and our username text, and we add a callback, which is a function that we can override from Rust, that then checks our password. And one important point here is we already actually make our lives a bit easier. We store the error message directly in a string, which is literally just calculating check password. That's all it does. We don't set this. We just declare that that's what it should be. Then we say, OK, we want a button. And that button should, that's the create account button, right? That should check whether we don't have any errors and whether our username has actually been entered. And then our password status is just a text field, which again does some calculations. And you can see here at the bottom again that this then again depends on our errors property that we've set up before. And then here's our check password function again. This looks very similar to what we had before. We again get our password and a username at the start, and then we just do some checks and return the errors, right? Notice that we didn't have any update code here, right? We never actually told the errors that we need to update them, ever. But this does work. If I enter a password here, and then I change the username, you can see that the error will disappear for matching the username. So how does this work? How does Slint know all of these dependencies? So, as I said, Slint compiles down to Rust. So we must have taught Rust this trick somehow. And indeed, Olivier has done so. And at the core of this, there's just literally a struct called property, which is a templated struct, so you can put not every bit of data in it, but a lot of different Rust types. And you can kind of think of this as a cell with this additional binding information, a cell that knows about when it needs to do work, a cache that needs to know when to do work. And the cool part is that to create a binding, so to create some dependencies between properties, you just write a normal closure or even a normal function. So this is basically more or less what the Slint compiler will generate us for our active button. There's literally just a closure that gets the errors and checks if they're empty. And that's it. What the heck? How does this work, right? So we can take a bit of a look inside of this magic today. And there's two parts to it here. There's getting a value out of a property and setting a value later. So reading a cache or creating it and invalidating it. And the algorithms here are actually surprisingly simple. So basically, if you try and get a value out of a property, it's a cache. So if the cache is valid, it'll just return it, and we're good. Otherwise, the property starts tracking its own dependencies. And it does that in a very clever way. There's just a thread local variable that is called current binding, which basically registers which property we're currently reading from. And that's pretty much all there's to it. And this is exactly what's happening here when we check the password. When we get the password from the API that Slint is generating, it literally just calls property get under the hood. So when we actually end up evaluating our button, for example, we just call get on it, and we remember that this is the binding we're currently evaluating. So the binding is a closure, we call the closure calls get on the next property. And now at exactly this point, the call stack here knows, okay, I just need to look up what the current binding is to figure out who called me. And so we can set up the link. And the same happened, and then we move over the current binding pointer and rinse and repeat, right? And this way, we need to remember to also pop the binding back again, but that way we basically have a stack that always knows what the last step was. And that way we can both calculate the value we need and figure out all of the dependencies involved. And the same, of course, happens if we, for example, then get the password status. And the cool thing is, everything is cached already. We already have our error list. We don't need to do anything. We just need to create this one link, and we're good. We don't need to calculate everything else again. This is also really important for UI work, right? I do not want to recalculate how big my database is on every frame. I just want to have that as a number that I can render. But what about the other side of the coin? What about that pesky cache invalidation problem? Well, it's also actually reasonably straightforward. We just remove the current binding because we're now in a, if you set a value in a cache manually, right, you're sort of telling it, okay, this is now the value you must have. If there was another expression you're trying to evaluate, sorry, forget about that. This is the new value. So we need to remove the current binding, and then we already have stored what dependencies this property has. So we just look at the dependency graph, see if any of the caches need invalidating, and then we mark them invalid, and do that recursively till we're done. One important point here is, at least in Slint, we do not actually recompute anything here. We just go through our dependencies and tell them, sorry, you're invalid. Try again next time. Also, as a side note, there are other models for this. There are, for example, the model that Qt and QML use, which is the push model, where when a property changes, all of the dependencies are indeed immediately reevaluated. And these have slightly different sort of implications. In our case, this means this is all very lazy. We just do the work we need, and we don't do anything we don't need. And in Slint, this is sort of called the push-pull model, where we push the invalidation and then we pull the actual computation. So when something actually changes, for example, if we modify our password, all that we do is we go along the chain, we mark our errors as dirty because we know they are a dependency. Then errors recursively marks its dependence dirty. And then we're done. If we then try to reevaluate, for example, the button active state, we know, oh wait, this is 30. And now we just redo the calculation and reevaluate the errors, and then we're done. And because we now know that the errors are again correctly cached, when we get our password status, the only thing we have to do is read the errors and we're done. We don't have to recompute all of the error list because it's again cached. And this already solves a lot of this sort of UI problem of there's so many different inputs that may change at any point and they're all interconnected, but it will still all just update correctly. Just one important thing to really be aware about is when you set a value, you will remove bindings. So as soon as you sort of go into the imperative world, you can screw with this reactive world. So be careful with that. And that's also where we still have a bit of time to go into some of the advanced trickeries of how to make the imperative world play nicely together with the reactive world. Because a very common problem you, for example, have is that you have multiple inputs that might be fighting for the same value. They all want to set that data point. You have maybe a drop-down that can set something, or you might have a dialog that contains a text field that actually in the end ends up setting the same internal value. Or, for example, we might want to determine the username at startup to pre-populate the dialog. That means we now have a text field that wants to set the value, and we have a startup script that also wants to set the value. In Slint, that means we have we need to change our property to be an in-out property, which means we can set it both from inside the dialog and from our Rust API. And if we then at startup load the username and set it, this will break because we're setting the property, right? We're setting our cache, but our cache has been set up to load from our name text field. So there's a conflict that we can only resolve by forcing the cache to a specific value and breaking the binding. So how do we fix this? And the typical solution to this is called two-way bindings. We want the binding to work in both directions. We want this value to both be sort of bound to the text field, but also to accept inputs from the other side. This is typically a very hairy thing, but in Slint, it's actually pretty nice. The only thing we really have to do is tell our username that, hey, you are actually two-way bound to the text field's input. And that means we should accept inputs in both directions. But then the point is, how does that work in Rust? Like, how does our property setup look like? And the answer is that in this case, we'll basically fake it a little bit and just say, oh, well, actually, this is not two separate properties that are fighting for the same value. These are two properties looking at the same value. They're just bound to the same value. But again, we have that problem. If we set one of these, this will break again, right? And this is where the sort of bindings that we've implemented in Slint have some kind of magic powers. And in this case, the binding that we've set up here is a special two-way binding that is not a normal closure, but this two-way binding knows that it should intercept the set call, which it can do. So when we evaluate it, it behaves like a normal binding. We just evaluate that chain here from our common property to the username. But when we set it, we just forward the set call onto our common property. So we will break the binding of that common property, which in this case didn't actually have one in the first place. And that's something usually you would want to avoid in a two-way binding setup anyway, to have the property itself then bind to something else because one of the source properties had such a binding. But our link between the username and the text input field stays active. And of course, we do the same in the other direction as well. And that way we can do two-way bindings in a way that from the outside just looks really intuitive and works really, really well. And internally just reuses the exact same machinery that we have for normal one-way bindings, but just allow it to go one level deeper and to forward things. I should also note that this is all very simplified in terms of what the Slint compiler will actually do, because it will try to optimize this stuff so that it'll get rid of some of the like some of these properties. Maybe it'll all just collapse into one property and then we don't have this problem in the first place, that sort of thing. But this is, if you were to use our property system to manually in Rust reconstruct a two-way binding, this is pretty much sort of the standard approach without optimizing it. And then there's a funny problem we had recently where we actually noticed some bugs. So I'm now trying out on all of you as my guinea pigs the new layout that we have for solving this problem, which is what if we instead want to have the user be a struct? That makes a lot of sense, right? We don't want to have just a random bundle of properties that are hanging around here. So we want a proper user struct that contains a name and a string. And then we want to be able to, from our line edit, set the name, right? We want to be able to just edit that one value, but we still want to be able to load the struct at startup to pre-populate the dialog. So now we have these, again, two values fighting each other, but they're not even of the same type. Like the property is a user struct, while the user property is a user struct, while the text property on the line edit is a string. So these are in conflict. We can't use the exact same trick that we did before, where we just all pretend it's one thing anyway and just forward everything. But we can use the same idea. We just have to make it a bit more complicated. And this is sort of the graph that you end up with. So what we actually have now is the actual user property, and we sort of have an overlay property, which is the name that is shared in our two-way binding with our text field. So this is our text field string, and then this here is the actual common property like we had it in the normal two-way binding case. And for any field that this string, this struct may have a two-way binding for, we will have one of these sort of shadow override properties. And what basically happens when we evaluate this struct is we will first use yet another property which contains the original binding from this struct. We will evaluate that first, and then we will sort of use a map to override that specific value. We'll override just that field. And that lets us both have a binding on the struct. So we could, for example, load the user struct from something at startup. We could conditionally recompute it from a function, but we could still have that two-way binding on that one specific value. And in this case, it gets even weirder because by default, we want this value to just be the value that the struct has, right? So we actually bind that value back to the original binding by extracting it from that. So at start, this basically will be a no-op, right? We will just read the original binding again. But as soon as we change something in the text field, we will break this binding here and start overriding the actual struct value. And that way you can get some quite nasty graphs where you can override basically different individual struct members from different links that even go through other globals or components, and then in the end just end up two-way bound via some roundabout routes, and it should still work. At least that's the theory. This is the approach we're trying right now. The old one was to have the common property also be of the struct type, but that caused some issues. So if you see any problems with this, let me know. We're still trying this. All right. But if you want to try this, and also this then is just a normal two-way binding again to that common thing that we had before. So this just does the same intercept set trick because this is now of the same type. So that's the easy part. And if you want to try this yourself, check out Slint. We're a UI toolkit written in Rust for Rust, but also other programming languages. So if you, for example, want to try it, you can also try Slint with C++, JavaScript, or Python. And it's, of course, all open source. In this case, GPL license, not MIT license. And there's commercial licenses available. For example, if you want to have your own embedded product that's not open source, you can do that with Slint as well. And we're also hiring. So if anyone's interested in dealing with all this kind of hackery, just get in touch with us via the email or just talk to me or Olivier. All right.
All right, questions?
Sorry if you're quite tired of this question, but what is your connection to Qt? Because there's some kind of connection, right?
You mean to the toolkit? Most of the Slint developers do have background with the Qt toolkit, so you can kind of think of this as an evolution of QML specifically, but we're really sort of trying to get that Rust spirit into UI programming, so do things at compile time, check everything. We want that experience of it compiles, it works. And at least for me, this has been such a mind-blowing thing with Rust in general, and now also with Slint and UI, that you could just rely on things actually working, which is super nice.
Maybe go to the get part.
So the graph or the algorithm?
But it's fine.
Mm-hmm.
So let's say that I'm a really good developer, and that let's say that I'm making a cyclic dependency between the user and main class.
Yes.
What happens?
So it depends, because we do a lot of stuff at compile time. Slint, the compiler, can usually figure this out, and it'll just error out on you at compile time, and will tell you, no, don't do that. I believe we also do check this at runtime. If you do manage to screw this up at runtime, I think you get a panic, right? Yes. So that is an unfortunate thing you can still do if you're really nasty, especially in your Rust code where we can't check everything at compile time. But because we check a lot of stuff at compile time, this is much less of a problem. But it is definitely one of the big problems with reactive programming. Similar to how two-way bindings are typically a problem, that is something you really need to avoid.
I mean, it can be solved through actually doing better job of but yeah, it will still happen.
But as a lot of people have found out, even especially with QML, where there aren't these compile time checks, this is still easy to screw up if you don't have checks for it, which is why the Slint compiler can figure this out for you. And especially with layouts, you can quickly run into problems with like the width is bound to the preferred width. You get error messages.
Any other questions? All right, thank you so much for your talk, Leon. All right, we have a lightning talk and then we'll do a quiz. So, Samuel Åkesson, how do I pronounce his last name?
Åkesson.
Åkesson. Samuel, on stage.
Let me get my cursor. I'm using Nero, by the way, but it's not really optimized. It's not really.
I had that exact same problem.
Yeah.
Just use the keyboard shortcut.
Yeah.
Just use Windows Shift and then arrow keys.
Perfect.
Okay.
So, my talk is about the question: are we Ratatouille yet? Because there's a lot of questions like: are we game yet? Are we GUI yet? Are we web yet? I think there's probably more. But yeah, I would say we are getting yet Ratatouille yet. So who am I? I am a Swedish student. I'm doing my final year of master's science, all that crap. So I am from the academia, but I'm also very interested in hobby programming. And I've only been a Rust enthusiast for like a year, but this year I've been grinding a lot of Rust. So I think I've dug a lot. Yeah. And I have a parasocial relationship with Orhun, so that's why I'm here. And I'm trying to make that into a real social relationship. So for these next 5 minutes, I will take you through my journey of porting Ratatouille to the Nintendo Switch, to PDFs, to SVG, and to UEFI. And also mention a few previous works. So first of all, Ratatouille on the Nintendo Switch. There already is an ecosystem for Rust homebrew on Nintendo Switch, so I really haven't done that much. I just linked together Mousefood, the fantastic no STD backend, with the graphics implementation in this Rust homebrew. And it just works. It's really nice. I don't know what to say, really. It's not a really hard architecture either. It's like ARM-based, so nothing too crazy either. And they even have an embedded allocator, so you can use Vex and anything. It doesn't really feel that bad. Yeah, that's my first. Next up, Ratatouille. Who here knows about types? Yeah, oh yeah, of course, because it's written in Rust. So types is a great alternative to LaTeX. And something that's great is that you can write plugins in any language that compiles to WebAssembly. And so, of course, Rust is a very good target for this. So Ratatouille is my library, which you can use to create your own WebAssembly plugins that emit Ratatouille widgets, basically. Because it's pretty cursed to get an interactive TUI in a PDF. But the thing that's crazy is types is so fast in rendering that you can have a live preview in NeoVim and just input the key presses you wanted to do, like HJKL, and it will render live when you press the key presses. So basically all I'm doing here is I'm importing my Ratatouille app, which was a WebAssembly plugin, and it only has one function, which is TUI. And then I just press the key presses. So it's a very pure Ratatouille app. Has no I/O except this string. Yeah, this is all I said. So yeah, nothing more. Like, it's not an interactive environment. It's just taking the deterministic string and making a PDF from it. Next up, Ratatouille. So you don't want an OS. You want to do this before the OS starts. So there already is a high-level crate called UEFI, which abstracts this very much. So together with UEFI and my library, Ratatouille, you can create Ratatouille UEFI applications. And I actually am using my own application, EFI Mux, to boot my Arch Linux installation. So it's written in Ratatouille EFI. I can show that maybe when I end this presentation. And probably the last one, which is not very cooked, Rata SVG. The idea is Ratatouille is so nice for layout, so why don't use it for graphic design? Basically, I'm not sure how the user interface should be, but right now it is a library. So you just give it a Ratatouille widget, and it renders it as an SVG. And I haven't even added configurable fonts, I don't think, but that shouldn't be too hard. But it would be really cool if you could have like a CLI that scans your code bases for Ratatouille widgets and makes SVGs from them. And what really inspired me is that Ratatouille has like they have like a graphic which they generate in every release, which I think you do by spawning a VHS tape and then screenshotting it or something like that, which is somewhat cursed because we have the characters. We should be able to do vector graphics, not bitmap graphics. Yeah, and I just want to mention some previous works. Mousefood is amazing. That's an embedded graphics backend. So anytime you can just draw bitmap, you can use Mousefood. And Ratzilla is Ratatouille on the web. Amazing. And I just found out when I published my Ratatouille FI on Awesome Ratatouille that someone already did it. Someone already beat me to it, Ratatouille in the UEFI. And there's more stuff like EUI, Ratatouille, and Bevi Ratatouille, I think. And there's really a lot of places. So basically, Ratatouille is the new Doom for Zoomers, basically. So I think the goal is to get Ratatouille running on a pregnancy test or something like that. My takeaways from this is I haven't really done anything. Like, there is surprising maturity in a lot of niche parts of Rust. And it's so nice to, surprisingly mature. And it's so nice to be able to use one language for a bunch of different places, like on the web, in a no-stud Nintendo Switch, and like, just works. Blazingly fast too. And here are some links. If you want, I can actually kill my laptop and see if we can see. I don't know if the HMI will work. Let's try. Maybe?
Let's take Matthes.
No, it didn't. Okay. But this is my bootloader, or I don't know what to call it. Yeah, it loads EFI applications. So I use it to chain load systemd-boot to load Arch Linux. Completely unnecessary. Okay, yeah, thank you. Yeah, can we take questions or?
I'm just speechless. Very questions.
I have a sort of related question.
Yeah.
Did you you were in Sweden, right? Like, and there was last event.
Yeah, I was in chat.
Did you happen to see the stream, live stream?
Yes, part of it. I think I remember your face actually. Yeah.
Yeah. So you remember my talk about this console, virtual console?
I'm not sure if I watched the entire thing. Sorry, I'm not sure.
Anyway, it's this virtual console, very pixelated and everything. Like
Yeah.
that. And I was just wondering, how do you like port anything to this Nintendo Switch? If you have anything that you want to port there.
Oh, if I want to port some application to it?
Yeah, that's it.
Yeah, that's a good question. That's the problem. I had a solution, but I don't have any problem I want to solve with it. So I can't think of anything I want. Like maybe some Tetris application, maybe.
No, I have a problem, and you have a solution.
Okay. Yeah.
So I have an app. I want to port it to Nintendo.
Let's do it.
So,
Let's make it happen.
Okay. Okay. Let's do the action.
Because the only caveat is it needs to be no stud. Then it can work probably.
It could be.
Yeah.
It could be.
Nice.
Awesome. Nice match. Any other questions? All right. Thank you so much.
Thank you.
All right, quiz time. We have some prizes too. I'm not gonna spoil it just yet, but some cool stuff. So let's do it, guys. This is a platform that we use. You just need to scan the QR code and you can just join from your phone. Wait, let's go back here. Full screen. How do I make this full screen? Does anyone know the 11? Ubuntu, by the way. All right, guys. Let's wait a bit. Are we all in? Yep. Yeah. I mean,
mean, don't join online, guys. I mean, you won't get the prizes anyways. Okay, let's get to it. Nice, 40 players ready. Are we ready? Starting. Hard question. No cheating, no cheating. All right. I think we get how it works. Damn. Let's go. Why do we have so much time for this? 10 more seconds. Blazingly fast. Did we mess up the quit? No, anyways. All right, guys, you ready? It's gonna get harder, trust me.
The page was different, I had to scroll. I didn't know.
Okay. You ready? There's actually this API that you can see the number.
How many of those are quotes?
What?
Sin. How many of those are quotes?
How many of them are?
Who's Richard? Nice. Keep going, man. Okay. Next question. Brain. There are 3 prizes, so you're gonna pick three people. Rat, 3 rats. All right, let's get it, guys. Let's talk about it later. Okay, how's it going? Bad? All right. Ooh. All right, let's see the leaderboard. Who's ST? Nice. All right. Question 8. Oh, hard one. This is difficult. Very slint. Wrong, invalid question. This is a little icebreaker. And curses. Bevy. Let's see who's fastest. Doesn't even show. Is fastest. I don't know. Okay, question 9. We're getting to the final questions. You guys were not listening to me. Yeah, Axum. Wow. All right, take a look at this, and then question 10.
I pressed some.
Yeah, borrowing and mutability. Question 11. Want to, by the way?
$600,000.
Yeah, OpenAI. Let's see the leaderboard. Any cousin? All right, last question. Okay, final results. Okay. Olivier, and Ertman, can we get you guys on the stage, maybe? Who are you? Who are you? You're who? Okay. Your username? Olivier and Ertman. Okay, guys, we have 3 prizes. I'll just show you. But maybe you can just hold the microphone for me. Hold it. Thank you. So first one. We give away 100 exercises to learn Rust from me, Matthes. Yeah, Luca Palmieri, this book. Second one, maybe let's show this one. All products pack from JetBrains. You can use all the IDEs. It's worth, I think, $1,000 and includes Rust Rover, of course. And finally, we have Ultimate Rust Bundle from Arden Labs. This is a course that contains, wait, where is that? Oh, yeah, Ultimate Rust Bundle. This is a beginner to advanced course. It's like 44 hours. Yeah, it has a bunch of content. It's worth like $600. So the winner gets to choose what he wants. Olivier, what do you want? Which one?
The JetBrains pack.
All products pack? All right, that's to you. All right, what do you want?
Maybe the book?
The book?
Yeah.
Here you go. And the Ultimate Rust Bundle prize goes to you. All right. Thank you everyone for participating, and this is it from us today. And now the networking time. Yeah.
Sorry? Yeah, thank you.
Just works. Amazingly fast. It's so fun that there's code running on Matthes because it's actively trying not to get to run code. Like this is
Guys, thanks for joining the live stream.
I need a night training.
You're still live. You're still live. If you want to say something to the camera. That was golden. That was golden. That was your moment right there. All right. We can do maybe an interview.
What?
We can maybe do an interview.
Yeah, sure. Maybe with the winner.
No, with you.
Me?
Yeah,
Okay.
yeah.
All
that's
right.
good.
Sure.
Yeah, just put it like maybe we can.
Yeah, good. But I think I already came on.
All right. So Roland, how is life, man?
It was awesome. I'm a bit disappointed that there was not more talk about Zig, but
Yeah, you came to the wrong meetup. Can you maybe move away because like you're right so much in the So
it's a bit yeah. All right.
so yeah, Zig meetup Berlin. How was it?
It was pretty good. I mean, lizards are better than crabs all the way, and no.
We're gonna actually kick him out now. Like,
Yeah,
what are you talking
Zig is a good language for people that like C, but we're better.
Yeah. So what changed since our last meet?
So I started working with Crab Nebula, one of the company that sponsors and subsidizes Tori, and we are working on the new European Resilience Act, Cyber Resilience Act, for making safe and secure software, and that will came into effect December 2027, and nobody's ready, so we're trying to help people get ready.
Nice. Congrats on the new position. And should we expect Charade version 2?
Charade version 2 is definitely in the books. I think Kimi is gonna get adapted for Charade, and we'll see how it goes.
Really excited for Charade, and
I think Charade on the Switch would be pretty sweet, actually.
yeah, you should hook up with Sermons about it.
Yeah. Mousefoot Charade. If we can find a way to make the image works, that should be nice.
Yeah, hopefully. Good luck with everything.
Thank you. You too.
Do you have any message to the world out there?
We need more beginner-friendly Rust documentation, especially for people that don't know how to program, because Rust is an awesome first language.
You heard him, guys. So thank you a lot again, and I guess see you in some other place. See you tomorrow. All right. Let's check the questions.
That's a problem I know how to.
All right, guys. I think we're done. Thank you so much for joining the live stream, and we're signing off. Because they are We're done.